Okay, so we want to do this integral. Really, we want to find this antiderivative. I don't know, my typing wasn't, or my whatever wasn't so great, but this is the square root of x squared minus 4. So when we have an integral like this, maybe there's sort of a checklist you can go through. Is this like, can you find an antiderivative right off the bat? And the answer is no. It's not like a polynomial or a sine or something like that. So we go on to the next thing. Is it a product of trig functions? Is it sine times cosine, tangent times secant, that sort of thing? No, so we're not going to treat this as a trig integral. So next, the next thing that we might want to look at is partial fractions. Is this a rational function? And again, no, it's not a rational function because we don't have a polynomial in the denominator. And so the next thing that we might want to look at is going to be trig sub. Does this look like a trig sub form? And it does, because we have, in the kind of hard part, the square root, we've got an x squared minus 4, and this sort of tells us that we might be thinking about trig sub. And if you just memorize what substitutions to make, that's fine. But I'm going to work through my reasoning on which substitution to make. So I'm always going to start with cosine squared theta plus sine squared theta is equal to 1. And over here, I've got the variable minus a constant. So I need to somehow make this look like a variable minus a constant. If I subtract sine squared or cosine squared over here, it's going to be constant minus the variable. So then the next thing that I do is divide this equation by cosine squared, in which case I'll get 1 plus tan squared theta. When I divide 1 by cosine squared, this gives me secant squared theta. And now this gives me tan squared theta is equal to secant squared theta minus 1. And so now I've got a variable minus a constant, which matches the form up here. And the only other difference is that I have a minus 1 here, but I need to have a 4 here. So if I multiply this whole thing by 4, I get something like this. And finally, I've got 4 tan squared theta is equal to 4 secant squared theta minus 4. And so this whole thing right here is going to be my x squared. So if x squared is equal to 4 secant squared, this tells me that x is equal to 2 secant theta. Okay. Also, if there's a table in the book, and if you just memorize whenever you see x squared minus 4, you want, or x squared minus a squared, then x is a secant theta. That's fine as well. I'm just telling you this is how I think through things. But really, the hope, again, like I've said so many times, is that you're doing so many of these problems that a lot of this stuff is just second nature, and you don't have to think through a whole bunch of it. It'll just happen. Okay. So when we're using a trig sub or any sort of substitution to change the integral, there's typically 3 things that we have to do. 1, we have to change the integrand. In other words, the 1 over x squared times the square root of x squared minus 4. 2, we have to change the dx. And 3, we have to change the bounds on the integral. Since this is an indefinite integral, we don't have to do that third step. But the next thing that we need to do is compute dx. So I'm going to do dx. If I compute the derivative with respect to theta of both sides, I get dx is equal to 2 secant theta tan theta. And if this is true, this implies that dx is equal to 2 secant theta tan theta d theta. Okay, so now I can go on ahead and start making my substitutions and replacements in this integral. So let's see, like this is equals. Okay, so I'm going to have my dx. So dx is 2 secant theta tan theta d theta. Okay, and I'm just going to take this one step at a time. In the denominator, I've got x squared. So this is 4 secant squared theta times the square root of x squared minus 1, or x squared minus 4. So this is 4 secant squared theta minus 4. Okay, there's a number of ways to do this next step, but I'm going to factor a 4 out of this and then bring it out of the square root. When I bring it out of the square root, it comes out as a 2. And I'm going to bring all of these constants out. I'm going to have 2 over 4 times 2 times the antiderivative of secant theta tan theta d theta divided by secant squared theta and the square root of secant squared theta minus 1. Okay, so now I'm going to use the fact that secant squared theta minus 1 is equal to tan squared theta. And for the values of theta under consideration, tan is positive. So secant squared theta minus 1 is tan squared. We take the square root. That gives us the absolute value of tan theta. But if tan theta is positive, that's just tan theta. And so what we have, the 2's cancel. And we have 1 over 4 times the antiderivative of secant theta tan theta d theta. And then in the denominator, we're going to have secant squared. And this is tan theta. Okay, so now we might be getting a little bit excited because it looks like stuff is going to cancel out nicely. So the tan thetas cancel. I've got secant theta over secant squared, so this is going to be just d theta over secant theta, but secant theta is 1 over cosine. So this is 1 over 4 times the antiderivative of sine theta d theta. Okay, the antiderivative, or sorry, not sine theta, cosine theta. Okay, the antiderivative of cosine theta is sine theta. So this is 1 over 4 sine theta plus c. Okay, but we're not done yet because the problem is given in terms of x. So we have to convert this back to x. And that's where we do the triangle thing. So I'm having a hard time here. So this is our theta. This is a right angle. And we know that secant theta is equal to x over 2. Okay, so secant theta is 1 over cosine. So we know cosine theta is equal to 2 over x. So cosine is adjacent over hypotenuse. So this is 2. This is x. So this is the square root of x squared minus 4. So then sine theta is opposite over hypotenuse. So this is the square root of x squared minus 4 over x. And so if that's what sine theta is, then over here, this is equal to 1 quarter the square root of x squared minus 4 over x plus c, and that is the antiderivative of that function over there.